Well, welcome everybody to the first webinar of 2024. I hope you all had a peaceful and restful winter break. Today, I'm really excited to welcome Dr. Piyush Jain, who will be sharing many insights about the record-breaking 2023 fire season in Canada. Dr. Jain is a research scientist with the Canadian Forest Service. His main areas of study include the meteorological drivers of wildfire ignition and spread, developing improved models for fire weather forecasting, and examining the implications of changing climate on historical and future wildfire regimes. I have the pleasure of having known Piyush for quite a while. We used to work together at the University of Alberta, and I'm very excited to have him here today. Before I hand the reins over to Piyush, I would like to acknowledge that both Piyush and I are situated on Treaty 6 territory. This territory is comprised of the ancestral and modern-day territories of the Nahio, Dene, Niitsitapi, Anishinaabe, Nakota Iska, and Métis. We acknowledge our shared responsibility to this land and to each other. So welcome, Piyush. I'm really looking forward to this webinar. I think we have a record-breaking number of attendants today. So with that, I'm going to hand the reins over to you. And one last comment. Anyone who has questions that come up during Piyush's presentation, can you please post them in the chat box? And then at the end of the presentation, we'll have a live Q&A where I'll present the questions to Piyush. So Piyush, I'll hand it over to you.
Thank you, Karen. So as Karen mentioned, I'm Piyush Jain. I work at the Canadian Forest Service, and I do research in fires. So a little bit of cognitive dissonance for me talking about the record-breaking fire season in 2023 on perhaps the coldest day of the year. It's I think minus 40 here in Edmonton, so I hope everyone's warm out there. So 2023 was a year of superlatives in terms of the fire season. I think every single person living in Canada was affected by the wildfires in some way, everything from having holiday plans disrupted or outdoor activities to, communities that were displaced due to evacuations, loss of property, and tragically the loss of life. But also there was a lot of anxiety around the fires, and I think it's seared into our collective consciousness. So there are a lot of personal stories that came out of 2023. I'm not going to talk about that today, though. Those stories are important and they will be told in the coming months by other people. But today I want to talk to you about what happened in 2023 from a data-centric point of view. So now that we've had, some time to look back in hindsight at what happened, we've been able to collect data and sort of maybe put together a picture of what were the drivers and what were the impacts of the 2023 fire season. I'll just get started. I don't seem to be able to advance. Let me try here. Okay, there we go. So first of all, I just want to acknowledge the team. There is a big, rather large group of us who are working on it, trying to do a fast analysis of the 2023 fire season. A lot of scientists from the Canadian Forest Service, and then some other collaborators from the University of Alberta, Thompson Rivers University, and Environment and Climate Change Canada. So I really would like to thank them all for helping get all this data, piece it all together, and help form the narrative around what happened in 2023. So what did happen in 2023? Well, very simply, a lot of Canadians' forests burned. So right now the number is just over 15 million hectares. There's an asterisk there. I'm going to get back to that on the next slide. But if we look at the time series using the National Burned Area Composite, which goes back to 1986, we see that more than twice the area burned in 2023 than the next highest year on that record, which was 1989, where over 6.5 million hectares burned. Records were broken in 2023 for area burned in Quebec, Northwest Territories, Alberta, and British Columbia. And on top of that, the Yukon and the Maritimes had the second highest fire season on record, on that record. And in fact, if you go back to even further than 1986 to around 1960 when we started collecting good fire data, 2023 is also the corresponds to the largest area burned on that record. So let me just make a comment about that area burned. So during the fire season, we depend very heavily on the agency data, and that gets filtered through the Canadian Interagency Forest Fire Centre. And the number that they have for the total area burned in 2023 is 18.5 million hectares approximately. And this is the number that you would have heard in the media. It's been well reported, and at the time, that was the best available data. Meanwhile, here at CFS, my colleagues compile the so-called M3 polygons. So this is using satellite data to basically try to infer fire sizes in real time. And if you look at that data, it's pretty close. It says about 18.5 million hectares, but you can also calibrate that data to past fire season data, and then you get a number closer to 16.4 million hectares. For historical data in Canada, the gold standard of data that we have is from high resolution satellite imagery, which is then mapped. This product is called the National Burned Area Composite, and is available from 1986 to present. We were very fortunate that the people that the team that generates that data were able to map 12 million hectares for 2023 already early. And if we combine this with the remaining hotspot polygon data and calibrate that against the historical record, what we get actually, and I'm calling it MBAC interim because it's a provisional data set, is we get an area burned of 15.15 million hectares in total. And so it begs the question, why is this number less than the 18.5 or which is reported by the other data sources? Well, it's mainly due to the fact that once you remove water bodies, which obviously do not burn, and you remove unburned islands, the area burned of individual fires can come down quite a lot. And there's an example there shown in the middle for a fire in 2023 from Quebec, and you can see there's a lot of structure to that fire. There's lakes in there, and there's areas where which were not burned, which are not often possible to see while the fire is being managed or monitored while it's burning. But the benefit of hindsight here is that we can see that some parts of the fire did not burn. And so those numbers typically come down. So 15.15 million hectares is our best estimate right now. And that may change a little bit as the data is refined in the future, but I don't think it'll change by much. And this is the result of that product, which I'm calling MBAC interim. So the combination of the early MBAC mapping and the M3 polygons. And I think it's, the amount of work that went into this by others to generate this data early. I think I decided just to have one map showing all of that. And I'll show this map repeated throughout the presentation, but this is the best available data that we have right now for what burned and where it burned in Canada. And I'll just give a special acknowledgement here to Rob Skaken, Peter Englefield, and Quinn Barber, who helped put all this data set together. So what burned and when? Well, we saw where it burned. When did things burn? So here we're able to use that hotspot data to give a time series for each province and territory of the area burned. So you can see Quebec. This is also ordered by the highest total area burned. So Quebec, which had the highest area burned in 2023, that mostly burned in June and July. For Northwest Territories, Alberta and British Columbia, you can see that period of burning was much longer, but maybe not as intense for any particular period, with the exception of September 22nd, which was actually the greatest area burned throughout the entire year, where over 450,000 hectares burned in a single day. You had burning in May and June in Saskatchewan. You had burning throughout June and July in Ontario, the Yukon in August, and then you had some activity in the Maritimes early on, of course, and I'll get back to that. So it's worth just highlighting some of the main events that occurred in 2023. Excuse me. So fire started late in April in Alberta in anticipation of extreme fire weather. The Canadian Interagency Forest Fire Centre set the national preparedness level to the highest level, which was 5. And that was May 11th. That was the earliest that's ever been set to 5 on record. In May 12, the Donny Creek fire was discovered in British Columbia. That ended up being their largest fire in history on record. On the other side of the country, meanwhile, in Nova Scotia, the Barrington Lake fire started on May 27th, right at the bottom of that peninsula there, and it continued to grow to over 23,000 hectares, 23,000 hectares before it was contained. It ended up being the largest fire in Nova Scotia's modern record. May 28, and due to another fire near Halifax, over 16,000 people were evacuated. Then June 1st, we had multiple fire starts in Quebec due to a series of lightning storms. And those fires grew very rapidly due to the extreme fire weather conditions, and brought smoke into New York City. And on June 8th, New York City had the worst air quality in the world. June 9th, a fire near Edson led to the evacuation of over 8,000 people. In fact, Edson ended up being evacuated 3 times in 2023 due to fire threat. In June was the smokiest month. Over 1,400 air quality alerts were issued from Environment Canada. One of the big fire days, excuse me, sorry, I went forward too quickly, was June 22nd, where over 400,000 hectares burned in a single day, mostly in Quebec. July had continued increased activity in BC and continued growth in Alberta, Northwest Territories, and Quebec. So moving on to August and October, August 13th, the hamlet, what happened there? Sorry. There we go. The hamlet of Enterprise was destroyed in Northwest Territories. August 14th, Canadian Armed Forces were deployed to the Northwest Territories. August 15th, there was a territorial state of emergency declared. And on August 16th, the entire city of Yellowknife was evacuated. And then on the other side of the country, almost simultaneously, we had the McDougall Creek fire in West Kelowna, where almost 20,000 people were evacuated August 17th. And then later that day into the night, in fact, the fire jumped Lake Okanagan into West Kelowna, so the west city of Kelowna rather than West Kelowna, and that resulted in almost 10,000 people being evacuated. I remember that event very well because we were actually holidaying at exactly that time in Penticton, which is at the bottom of Lake Okanagan, and we were worried about how we were going to drive home on the 18th. So that's very much seared into my memory. August 18th, the provincial state of emergency was declared in BC. September, both British Columbia and Northwest Territories renewed their states of emergency. Now, the biggest fire day I mentioned earlier was September 22nd. Nearly 450,000 hectares burned in a single day. And that's largely due to strong winds and fires, which were already very large. And I'll get back to that a little bit later. And in October, many fires continued to burn in Alberta, British Columbia, and Northwest Territories, but conditions stabilized and the season started to really wind down. So that was a really quick overview of 2023. I'm sure I've missed out some of the very important events, but I I think that just gives us a little bit of an overview of the timing of events, and also the appreciation that fire, there was a lot of fire on the landscape in 2023, but that fire was distributed throughout the country in both the west and the east. And that was what was one of the factors that was quite unusual about 2023. So I mentioned evacuations earlier. Those are listed on the right. There are the top 10 evacuations on record since 1980, and 5 of those occurred in 2023. In terms of total numbers of evacuees, there was almost 240,000 people evacuated. And that was, I think it was around 238, I can't remember the exact number, but evacuations, evacuation orders. And you can see an example there, a fire encroaching on Yellowknife, which led to the entire town of Yellowknife being evacuated in August. So one of the big stories for 2023 was the amount of smoke generated by the fires in Canada and the very poor resulting air quality. So this is some data from Jack Chen from Environment Canada, based on one of the model that they run for forecasting air quality. So using a standard from the Canadian Ambient Air Quality standard, which is basically that if you have a mean daily value of PM2.5, which is greater than 25 microns. So that's basically the density of very small particles. And those very small particles, so-called PM2.5 particles, so can get into the lungs and cause cardiovascular disease and other short-term health effects. So that's one of the most important pollutants that we monitor for assessing air quality due to smoke. So you can see the number of days that exceeded that threshold were very high in 2023 on the left there, particularly around that area of intersection, the North Alberta, Northwest British Columbia, and Southern Northwest Territories. So that area. But when you can also see Quebec had a lot of days of poor air quality. And in fact, when you, on the right-hand side, when you look at the extremes that happened in 2023, so this is the maximum value of that PM2.5 level that occurred, you can see that there was very extreme, there were days of very extreme levels of PM2.5, both in the West and throughout Quebec. And just to give you an idea of what those numbers mean, typically if PM2.5 levels are between 50 and 150, people who are sensitive, who have sensitivities to air quality, should stay indoors. Above 150 to say 200 or 250, people should curtail their activities, and basically above around 250 and 300, it's hazardous to actually go outside. So you can see that there was a large parts of Canada that had hazardous air quality levels on at least one day of the year. In terms of air quality alerts, this is data from Environment Canada. If you just compare a few years going back to 2018, I won't go into the details here, but I think it's clear to see from the color map, which shows the amount of alerts for each year and in each region, that 2023 really stood out for both in terms of number. And in fact, if you're looking closely, you'll notice that they had to add a new color onto the color bar that they previously used. The pink, which was the number of days of air quality alerts, 135 there, in high level. But also, you can appreciate the fact that there were very high number of air quality alerts, both in Western Canada and in Eastern Canada. In terms of like a summary of those air quality alerts by month of year, you can see that 2023 really stood out here. The next highest year, 2021, in July 2021, that corresponded to the heat dome event, of course, that generated very extreme fire weather and a lot of fire activity in Western and Central Canada, starting late June and going into July of 2021. But 2023 had a lot more extreme exposure to smoke because of the extensive burning and the amount that was burning throughout the country. So in terms of exposure, we're able to take population data and come up with some quick calculations of what that exposure was for typical Canadians. So Canadians experienced 8 days of poor air quality, where we use that threshold that I gave on the earlier slide. But that was quite heterogeneous, meaning that in some parts of the country it was much higher. So it was 17 in Alberta and 44, a staggering 44 days in Northwest Territories of very poor air quality. In terms of census metropolitan areas, you can see that there were some areas where it was not so bad. Alberta was particularly bad with 18 very poor air quality days, and Edmonton having 21. And then, of course, Montreal and Toronto, which were closer to the fires, in Quebec, had quite a high number of poor air quality days as well, and exposure per capita. One of the big stories, and when a lot of us at Canadian Forest Service started getting a lot more media requests, was when the smoke from the Canadian fires from Quebec started moving into the eastern seaboard of the US. And in fact, in June 8th, I think I mentioned earlier, was New York had very poor air quality, and in fact had the worst air quality in the world for that day. And one of the reasons for this, I'll just play this video on the right-hand side. There was a low pressure system sitting over the Maritimes. And I think you can see that here on the right-hand side. And that created the cyclonic flow, which basically acted like a conveyor belt and pulled the smoke from the Quebec fires, I'll play that one more time, down into New York State and New York City. So in terms of fire management, because of the extensive burning in Canada and the amount and the, I guess, the number of places that were burning, there was very extensive fire management response. So on the left, I'm showing the various fires from agency data. The ones which are red were fully responded to. The ones which were yellow have a modified response, so they were suppressed if needed, and the ones in blue are monitored, just in case they need suppression, or at least they're within the area where they monitor fires. So you can see that there was a lot of fires, which were a lot of those large fires, particularly in British Columbia and Alberta and southern Quebec, had full response. And because of the extensive burning in Canada, as I mentioned earlier, the days that CFC was at the highest national preparedness level was 133. And if we look at the sort of the historical record, we see that that's the most number of days since 2003 that they've been at that alertness level in any particular season. In terms of resource sharing, Canada received firefighters or resources from 11 different countries, and there was over 5,000 international personnel deployed to Canada. So the fire management response was extensive. There were a lot of people involved, and I imagine it was took a great toll on the community to manage all of those fires. And of course, not all of those fires could be managed, and because of the extensive burning. So just in terms of extreme fire behavior, I think it's interesting to look at so-called pyrocumulonimbus events. So these are sometimes called firestorms. So how these events occur, it's basically the heat generated by the fire and the moisture that's either released by the fire or is already in the atmosphere is pushed into the higher part of the atmosphere, into the top of the troposphere by pyroconvection. So that is the heat of the fire. And there it cools down and it condenses and it forms a thundercloud. And sometimes those thunderclouds, as an example there shown for Sparks Lake, sometimes those thunderclouds themselves can generate lightning that can start new fires. So fires can be can be caused by the thunderclouds, which are generated by fires. So it's a positive feedback that can occur. In 2023, this is data shared by our US colleagues, there was 140 pyro-CB events identified in Canada. That's out of 164 globally. So the majority of events that occurred in 2023 occurred only in Canada. And most of those events occurred in July. There were some days, and the example I show here, this is a video generated from GOES 18 data, which can show basically, just explain it briefly. It shows the GOES 18 band 13, and you can apply a formula to that to get the brightness temperature. And the only thing you really need to know about that is that when the brightness temperature drops to below about -40, that corresponds to that's the cloud top height temperature, and that corresponds to the development of thunderclouds from fires. So there I'm showing the location of the fires. I'll just play this video. And it's this is at around in the evening of the 17th. Of the 16th of July, sorry, because that's UTC. So I'll just play it one more time and I'll pause at the time. It's around 11, around here. I think you can see suddenly there's a lot of those dark blue patches appearing, and that corresponds to the generation of those pyro-CBs. So in fact, there was 9 events identified on that one day. So that's what happened in 2023. Why was 2023 so different from previous years on near record? Well, one of the stories was that there was a lot of very, very large fires. Excuse me. So it was approximately 6,500 fires reported in 2023. The average is in fact 8,000. Going back over the historical data. So there wasn't an exceptional number of fires, but what was exceptional was that how many large fires there were in that record. So 20 of the largest fires were responsible for the total area burned. So if we look at the map on the right there of all of the fires that burned in 2023, this is the 20 largest, and that was responsible for half the area burned. The median duration of those fires was 100 of those largest fires was 103 days. So those fires burned for a very long time, months. And there were 5 fires of particular note there, which were over 450,000 hectares, including one on the top left there, which I'm going to show you more closely, which was over 1 million hectares. It was 1.15 million hectares. So as I mentioned, there were many fires and they burned for months. So this is a plot. This is an idea that Steve Taylor at CFS had for plotting the cumulative area burned for fires that started in each month separately. So and on the very left, you see the area burned by day cumulatively for fires that started in May. And here it's fires that started in June, July, August, and September, and so forth. So you can see that fires that burned in May, June, and July, for the most part, burned for a very long time, and the area burned from those fires continued to increase throughout the season into September. So fires that burned, a lot of those large fires that started in May burned right through to September, and the same for June. So one of the reasons 2023 was exceptional was these fires started early and they burned for a very long time. So why did fires start to burn early in 2023? Well, actually, first of all, I'm going to show you a video of that very large fire event, and then I'll get back to that question. So I think I'm going to sort of play this without too much comment, partly because it's nice to watch videos, but this was the largest fire complex, which doesn't actually have a name, so I made up the name for the fire complex. But feel free to throw your own name into the chat, or if someone actually knows the official name for it, please let me know. I did ask around. I'll play that one more time. I think the thing to appreciate is that there were several very large fire events that ended up merging into one complex because this fire burned for so long. And the second point I'd like to make is that, for a lot of the time, the fire just continued to smolder away. But then you had days of extreme fire weather, either through winds or through heat or dry conditions, and then the fire grew very quickly in those days. So there was just a few days that most of the area burned, but because the fire was essentially not extinguished until a late season rain event around September 24th, it continued to burn, and it waited for those days of extreme fire weather to occur, and then it took large runs. So that's how that particular fire got so big. So what were the meteorological drivers? Why was 2023 so exceptional, and why did fire start so early? Well, one of the pieces of the puzzle is that snowmelt was very early in most places throughout Canada. So on the left, it shows the snowmelt timing. This is from data from the US National Ice Center. And it shows particularly through Alberta, Northwest BC, and some of Northwest Territories, the timing was very early. There was snowmelt in early April. And in fact, when you look at the anomalies, so there's the number of days departure from normal, you see it was early over many regions of the country, including Quebec. So there was early snowmelt. What about the drought conditions? So this is data shown on the left from the North American Drought Monitor for each province or territory. I actually believe it includes Alaska there as well on the bottom right. So essentially, if we look at the dashed line is the 2022 data, and the solid line is the 2023 time series, sorry. So in Western Canada, if you look at Alberta and BC, for example, going into the winter of 2022 and 2023, it was already in very high drought conditions. And then basically that drought was carried through into 2023. However, in the east of the country, particularly Quebec and Nova Scotia, you can see that, in fact, there wasn't drought conditions coming into the season, but very quickly in May and June, those areas had drought intensification very rapidly that caused some of those extreme fire weather conditions. So another way of looking at this is we look at the drought code, which is one of the indices we use for the fire weather index system to assess fire danger. And you can see in May, it was very extreme in Western and Central Canada. And in June, in fact, it became more extreme in Quebec as well. That's looking at standardized anomalies of the drought code. Excuse me. So early snowmelt, drought conditions either from 2022 carrying over or intensifying in 2023 in the east. Let's talk a little bit more about that rapid intensification of drought in Quebec. So what I'm showing here, I'm using the satellite-derived data from that's assimilated into a land surface model to look at basically the root zone soil moisture. So this is basically the moisture about a meter underground. And then you can look at the time series of that, and you can look at the maximum drying of that layer in a 2-week period. And you see that between March and June, the most rapid drying that happened in 2 weeks was occurred predominantly in eastern Ontario and southern to central Quebec. And you look at the timing on the right-hand side of that, that basically corresponded to when the fires took off in Quebec. So there was very, very rapid drying, and the timing of it was such that it occurred when those lightning storms came along and started all those fires in Quebec. So that'll be something we'll be studying more, and it may be we're hoping to look at and see whether that was actually an example of so-called flash droughts. So that the other part of the story is that we had sustained early season, but also sustained extreme fire weather. So I mentioned earlier, one of the main tools we have at our disposal for assessing fire danger is the Canadian Fire Weather Index system. So many of you will already be familiar with that system, but just very briefly, it essentially takes temperature, precipitation, wind speed, and relative humidity measured at the surface, and it combines those four weather variables to give you different metrics of fuel moisture, so a proxy for fuel moisture, and also fire behavior. So how dry are the fuels and how likely are they to burn? And if they are burning, how likely is a fire to spread? So when you look at mean FWI values there on the left for May and June, you see that they were quite high in May for that region in Western Canada, and for June they were quite high for Quebec, particularly where those fires occurred. And if we look at the area of the forested area of Canada where those FWI values exceeded the 95th percentile, the historical mean of the 95th percentile. So another way of saying that is, from the historical period, what do we define? We have this threshold that we can define as extreme weather. And in 2023, how often and over what area did we exceed that extreme threshold? And we see that over 1/3 of Canada's forested area there for at least a day in May was under extreme fire weather conditions. And in fact, extreme fire weather conditions were well above the norm right through from May to July, and it came down to more normal levels, but then of course isolated extreme weather events drove those fires that had already gotten very large and caused them to get even bigger. So if we look on the top right, we see the daily area burned. I've shown that plot already by province and territory. And the bottom left is the corresponding area which is experiencing extreme fire weather, such as, similar to what I showed in the previous plot. And you can see more or less things line up pretty well. We tended to get more area burned on the days when we had extreme fire weather conditions occurring. And there's two examples there, particularly the two largest days of area burned. One was June 22nd, and that corresponded mainly to area burned in the east, so in Quebec and to a lesser extent in Ontario. And then September 22nd was the largest area burned in a single day, almost 450,000 hectares. And that was due to fire activity in the Northwest Territories, Alberta, and British Columbia. Interestingly, that doesn't seem to correspond to extreme fire weather conditions. But what happened on September 22nd is we already had a number of very, very large fires. So they had a very large perimeters where we only needed a little bump in the fire weather conditions. And that was also actually combined with very strong and gusty winds from a cold front that was moving through that area. And that was enough to cause very, very rapid fire growth. So in fact, if you just looked at FWI, you wouldn't think that would be the most extreme fire weather day, but a fire growth day, but in fact it did end up being that way. And we're still studying what exactly happened on that day from a synoptic weather point of view. So none of that data is available just yet, but we're hoping to do an analysis and figure out the drivers of the fire growth throughout the season. So I think I mentioned this earlier, but one of the other factors in 2023 was sort of the lack of large rainfall in some areas of the country. So this data shows this is relative, this is like the fire season precipitation deficit ranking. So that is the driest areas in terms of rainfall are shown in red relative to the 1940 to 2023 period. So you can see that the most record-breaking areas in terms of lack of precipitation occurred where many of those very large fires occurred. So the point to make here is that basically those fires were allowed to burn and get very large because there was not a lot of precipitation in those areas. And a lot of that precipitation was quite late season that did occur. So in that Western Canada region, for example, I think I mentioned earlier, September 24th, there was a large precipitation event, and that's when some of that very large fire growth finally stopped in that area. I think it's worth talking a little bit about fire ignitions. We're still collating this data, so this is very preliminary, but historically, throughout Canada, 75%, of fires are lightning caused, and this results in 91% of the area burned. 2023 was a little bit different. From the data that we have on hand right now, only 59% of fires were lightning caused, but this actually resulted in 93% of the total area being burned. So from that perspective, lightning was actually a more efficient ignition agent in 2023 than historically. Another interesting fact, which has been shared to me from Environment Canada, is actually 2023 in total had the third lowest amount of lightning on record. That goes back to about 1998 from the Canadian Lightning Detection Network system. So there's an interesting analysis to be done there. Did we just get unlucky that the lightning that we did get happened to be when and where extreme fire weather conditions were occurring and ignited lots of fires, or is there some more nuanced story to be told about that? So just for my final section, of course, one of the big questions in 2023, we got a lot of questions about this, was what role, if any, did climate change play in the 2023 fire season? Excuse me. So, well, first of all, general comment, 2023 was hot. It was a very, very hot year. So globally, and this just came out a few days ago, although other meteorological agencies have also made the same assessment. Globally, 2023 was the hottest year on record. This is from data from the European Centre for Medium Range Weather Forecasting. So relative to the 1991 to 2020 average period, it was 0.6 degrees warmer. Relative to the pre-industrial levels, it was 1.48 degrees warmer. But if we look at what the temperatures were during the 2023 fire season in Canada, it was even hotter. So the plot on the left shows the temperature anomalies over Canada. So it was hotter than normal over the entire country during the fire season, essentially. And if we look at the record-breaking values on the right, so this is the ranking of the temperature, mean temperature over the fire season relative to the period 1940 to 2023, we see that for most of the country, it was the hottest year on that record. And in fact, I imagine for globally at least, they're able to say that probably 2023 was the hottest year globally for at least 125,000 years. And I imagine Canada similarly was one of the hottest years on for a very, very long time scale. Although I haven't looked at the specific data for Canada yet. So what does that mean? What role does climate change play? Well, we can already see that if we look at two different metrics of extreme fire weather, so one was the fire weather index that I've already mentioned, and one is a much simpler index called the vapor pressure deficit, which is essentially a measure of how dry the atmosphere is. And so if we just look at that subset to the Canadian forested area, and we look at the sum of area, the mean area basically for each fire season, which exceeds that 95th percentile in each case. So how extreme is the fire weather over the entire fire season? And we look at the time series from 1940 to 2023. We see that 2023 really stood out, but we can also see that there is a trend and that in general, extreme fire weather is increasing. Not so obvious for the fire weather index, it maybe emerges a bit later. And that is because the fire weather index is a more complex combination of different variables. But certainly for the vapor pressure deficit, we can see quite a strong linear trend there where essentially Canada's forests are drying out. And I'll mention that there have been a couple of studies now directly linking wildfire or fire weather to climate change. So the science has evolved now where either statistical or climate models can be run so that they can be compared. So the weather conditions or climate can be compared between what is observed now and what would be observed if we did not have the amount of CO2 in the atmosphere that we currently have. So the so-called looking at the forcings due to the current CO2 levels and then the forcings due to just natural variability. And then in this way, these studies are able to attribute how much of a change in weather or sort of derived quantity like area burned from weather changes due to climate change alone. So this study from California earlier this year on the left, they found that nearly all the increases in area burned in California since 1971 can be attributed to anthropogenic climate change. In a very rapid study in Quebec this year from some of my colleagues and others from the World Weather Attribution Study, found that seasons of the same severity as the 2023 fire season are 7 times more likely under climate change, and with the same fire weather extremes are twice as likely under climate change. So I'm going to thank everyone there. Yeah, so as I think I mentioned earlier, there's ongoing work to analyze the 2023 fire season, and with my colleagues, we're hoping to put out a publication in the next few weeks. So I hope to keep everyone posted on that. This was a sneak peek, I guess, of some of those results. Yeah, so thank you, everyone, and I look forward to taking some questions.
Thank you so much, Piyush. I did post in the chat, but I'll just let everyone know. I know our scheduled stop time is in 10 minutes, but Piyush has very kindly agreed to stick around a bit longer. So if you're able to, we'd love to have you stay. He's agreed to an extra half an hour if we have so many questions. So, and for those of you that need to go for other commitments, this is being recorded and we will share it on our YouTube channel at Canada Wildfire. So Piyush, before I make my way to the very active chat box, I have a couple questions for you. And I was just wondering, when you talk about the number of large fires, so 6,657 versus an average of 8,000, do those take into account unique ignitions, or is it whittled down when fires eat other fires or merge together?
Yeah, that's a good question. So that was a total number of fires rather than just the large fires. But yeah, so the way the number of fires are reported by agencies, often like a complex or multiple fires, especially over a border, can be reported as multiple fire events. but when they're mapped, finally mapped in hindsight, that may be identified as a single event. So that number of fires can change. So we try to make sure we only use one data set when comparing that. So like we'll just use agency data to talk about the number of fires, or we'll just use MBAC to talk about the number of large fires, for example. But we won't try to compare between the two data sets because of the different ways that fires can be reported.
Thank you. All right, we had a very active chat during your presentation. I'm just going to read some of the questions and answers that were provided by other experts attending the call, and feel free to chime in if you have anything extra to add. So we had some questions around why you're not showing data from 1966, or whether or not it was available to the public. And it was shared that data prior to 1980 is usually not as reliable. The National Burned Area Composite is based on satellite imagery, so the reliability can be very variable prior to that. It's also noted that the quality varies a great deal depending on where you are in Canada. Detection efforts were less than uniform in the 60s, especially in the north. Do you have anything you'd like to add, Piyush?
No, that sounds right. I mean, yeah, there is a danger of mixing different data sets and trying to, extend a time series that way. So I decided I'm just going to stick with MBAC on that plot that I showed, because the fires are consistently mapped during that time period, and that's the most accurate data set that we have. So, but I think going back to 1960, there's no suggestion there was any year as big as 2023.
Okay, perfect. Thank you. There is also a question regarding the satellite data that you used, and the person would like to know whether or not this includes surface fire burns. Do the trees have to be scorched, canopy burnt in order for the area burn to show up?
That might be a question for the fire mapping team, but I don't think so. I think if surface fuels also burn, that'll show up in the satellite imagery. But I could be wrong. I'd need to check with the fire mapping team.
I'm just trying to find my way back. You guys are putting so many questions, it keeps kicking me to the bottom of the queue. All right, that question I will save who asked it, and I'll forward it to you, Piyush, in case you want to send them a more detailed answer after the fact. Piyush, could you comment on the fire weather conditions in Northeast BC, a part of the boreal plains where fires have historically been few?
Yeah, I guess that particular whole area, like at the intersection of British Columbia, Alberta, and Northwest Territories, it was an extreme drought going into the 2023 fire season, but also throughout the 2023 fire season. There was also a lot of, I didn't talk about this today, but when you look at the large scale weather patterns, so like atmospheric ridges and blocking, there was a lot of blocking events that lasted for a very long time, particularly in the western, and repeated blocking events. So the fire weather conditions, the fuels were very dry, essentially, extremely dry in the area of the country.
Thank you, Piyush. There is a lot of discussion around fire cause, lightning versus human. I think between the people in the chat and your slides, you've answered most of that. Make your way down. A lot of people were acknowledging air photos as a possible future data source, but again, it's a different temporal resolution to them as well, and requires a lot of manual interpretation in order to be able to use them. So there's one comment that the smoke lofted by pyro CVs gets over Eastern Canada in 2 days. They observed it with the MPL-CAN LiDAR network, and there was a link shared here in the troposphere and lower stratosphere, which is great. Thank you for that, Bob, if anyone wants to check out that link. There's also some questions about the large border complex that you showed, and people shared that it was the fire on the Territory BC-Alberta border, or fires, multiple fires there. So we have seen a heat dome in the summer of 2021, as well as you said, horrendous drought in 2022. This comment's coming from Alberta, by the way. In many parts of Alberta in 2022, this person is observing that they got the last rain in July 2022 and no rain until June 6th of 2023. So I guess just more support for that extreme drought conditions, which leads me to a question. You at one point mentioned flash drought, and I was wondering if you could explain that or define that for us, please.
Yeah, I'm not an expert in flash drought by any means, but it's the idea that you can go into drought conditions on a very rapid timescale and it'll persist for some time. So there are different formal definitions in the literature, but it's basically that just the idea that you enter drought-like conditions in a very short period of time, relative to the longer scale drying that might get you to drought conditions, which normally occurs. And I think there's some research showing that these flash drought episodes or events are increasingly common due to climate change. So
Thank you. That was my next question. So I also have a question here in the chat asking if you have taken the time to compare the extreme fire weather days specific to ISI or initial spread index.
yes, actually, we did look at ISI and BUI to try to pick out the wind events. And in fact, we also looked at 100-meter winds for some of these events. Some of that work is still ongoing. There's so much to look at. There's a crazy amount of large fire events and weather data to pour over. So there's only so much that has been done in the time already, but we're hoping to do some more analysis on some of those things.
Thank you. There was also a observation from Alberta that they observed earlier than usual lightning in 2023 in the first week of May, which is interesting to note. Mike Flanagan also thought that perhaps there was less lightning overall due to smoke, which is a cool thing to consider. And I was also wondering if perhaps the drier surface conditions could inhibit convective potential. Be interesting to look into what some of those drivers are for less lightning. So do you have any predictions as we head into 2024, Piyush?
No, but you know what? I knew someone was going to ask that. So I have a few slides at the end, but I'm going to basically just show you some of the data that I found online and give no comment because I do not have a crystal ball. But if you look at snow anomalies from Environment Canada data, despite the fact that we got a bit of snowfall here in Alberta in the last few days, you can see that basically there's still less snowfall or overwinter precipitation than is normal at this stage of the year. And that's possibly and probably largely driven by the fact that we're in quite a moderate to strong El Nino phase, and that usually results in less snowfall over Western Canada than normal. So that's one thing. Drought. So this is the drought monitor for I can't see the date there. January 4th. So you can see a lot of Western Canada is still in drought conditions, either severe to extreme drought. Throughout the area where we experienced a lot of fire last year. Another way of looking at drought is looking at soil moisture drought indicator. This is from the GRACE satellite product. So I'm comparing about the same time of year, 2023 and 2024. So you can see we've basically stayed in drought-like conditions. And in fact, now northern Quebec is also in drought conditions, which are persisting, and so is much of Nunavut. So yeah, so drought conditions persist, particularly in the west. And then this is the multi-model ensemble forecast. I just chose 1 month, April 2024, and this is put together by the World Meteorological Organization. So their prediction is basically for April that it's going to be hotter than normal. Uh, Precipitation is going to be about the same as what is normal. Um, and there's largely model agreement in those two predictions. So yeah, put there without too much comment. But yeah, I guess most people will be able to piece together that we should be on high alert for 2024.
Thanks, Piyush. A lot of comments just complimenting the work it took to put all this together and interest in future collaborations. There is one question about focused on Ontario. So Ontario had a high FWI, but did not seem to have the same wildfire activity. Was this perhaps due to more precipitation?
Yeah, that's a good question because I've started talking to that about that with some of my colleagues about what would have happened in 2023 in Ontario, because it did have extreme fire weather conditions, and it did have, particularly in eastern Ontario, sorry, it had those drought-like conditions occurring. Yeah, so it could have been the timing of ignitions, the timing of lightning occurrence. It could have been, fire suppression could have played a role there, how effective initial attack was on some of those fires. But also precipitation. Yeah, so I haven't looked specifically at when and where rain events occurred relative to those fires in Ontario, but it's a good idea to look at that and see why perhaps Ontario had a different level of fire activity. Having said that, I think Ontario still had the sixth highest fire season on that record from 1986 to current. So it was still above average in terms of the amount of fire area burned. It just was not as extreme as some other parts of the country.
Yeah, I would hazard that smoke also played a role on multiple fronts there, both in terms of insulative impact, but also human behavior changes. Just this person notes 2023 had the most AQHI or air quality health index of 10 plus days. I think a lot of people that would normally be outside camping, squatting and such were sheltering indoors for a good part of the season as well. Referencing evacuations. Are other evacuations such as First Nations towns and villages included in the numbers that you showed?
Yes, I believe they are. Now, I should give credit to Dawn McVitie, who compiles this data with some other people, I think. And the data is still provisional, I should state. So a lot of those evacuation orders and the numbers need to be double checked. That's the best data that we have right now. I believe it does, and I didn't show that, but it does indicate the number of Indigenous communities that are evacuated and where those are, and but I did not show that data today. So
There was one note in the comments that the numbers may be off by as much as 50%. As many of rural municipal residents may not have been included in those numbers. So I'm not sure what source that's coming from. If Stephen, if you'd like to post your source or where we can find that, that would be great in the chat. Thank you for that. All right, Piyush, is the 95th percentile an accurate threshold for extreme fire behavior given recent outlier wildfire years, particularly in British Columbia? And do you have any ideas on which percentiles are representative for normal, new normal, and extreme local fire weather?
yeah, I mean that's an active area of research. I use the 95th percentile across the country. It's a locally derived because it's easy to apply that threshold rather than try to calibrate a different threshold across different regions. And the other factor, I mean, here to consider is that, for example, in Western Canada, in the prairies and the boreal plains, etc., you will quite often get quite high extreme values of FWI. in Quebec, the values will not typically be as high, but relative to what their normal is, can still lead to extreme fire weather. So it sort of makes sense to look at percentiles from that point of view than to pick just a fixed threshold. Because if you pick a fixed threshold, Quebec would not have had extreme fire weather in the same way that Western Canada did in 2023. So, yeah, whereas if you look at it more from a climatological point of view, it seems to make sense in terms of what we observed.
Thank you for that. There was a question about whether or not you had comment on if the heat dome of 2021 may have played a role in the Northwest Territories this year.
In 2021 or this?
Oh, sorry, yes, in 2021.
Right. Yeah, I have to remind myself actually of what burned in 2021 in Northwest Territories. I can get back to that person. I cannot remember the extent of burning. I know British Columbia obviously had a huge fire season in 21, but it also extended throughout much of the country all the way into Ontario. So
All right, I can share these questions with you after, Piyush. This is a good question. I'm not sure if you can answer or perhaps point them in the correct direction, but this person would like to know, according to the record-breaking 2023 fire season, is there anyone assessing wildfire impacts on peak flood flows? I can think of one person, but they've since switched their career. I'm not sure if anyone else has suggestions for this person to reach out to. If please post them in the chat. Piyush, do you know of anyone doing active research in this year or 2023?
yeah, I can't. I know it's a question which comes up, particularly in British Columbia. Where they'll have a big fire season and an atmospheric river will come along and dump a lot of water. We had some big events like that, but I don't know who is currently studying that, or if it's being studied for Canada.
Hopefully someone knows someone is able to post a reply in the chat on that one. There's a bit of comment around fires taking quite quick runs. So there was a note that on August 13th in the Northwest Territories, they had a fire run 44 kilometers into the night. Asking if Quebec experienced similar. It was acknowledged that they were seeing similar run events in Alberta. And then we have a reply from Quebec saying they'd runs in the range of 30 kilometers, but not at night. I don't know if you have anything you'd like to add to that, Piyush. They're quite specific.
Yeah, we're only just starting to look at that one fire that I showed the growth of. That was only from data I basically put together yesterday. So looking at these individual fire events, yeah, I don't have any numbers or perspective to give on that right now, but we do have the data, so we may be able to look at that.
Those are quite often numbers you can get out of the after action reviews and reports from the provinces and territories if they make them public as well. I know there are many underway right now by third parties. So this person would like to know, are you aware of any studies focusing on ocean atmosphere indexes in 2023? I'm interested in effects of speed of transmission of La Nina to El Nino, for example, and negative Pacific decadal oscillation that featured above normal ocean temperatures across the North Pacific.
Yeah, I'm not aware of any studies. There will be studies, obviously, but I'm not aware of anything that's come out relating to fire in particular. I know that year end onwards, ocean temperatures have been getting hotter and hotter. So 2023 had the warmest surface ocean temperatures in history. So undoubtedly that the teleconnections that result from that will have a large impact on what was observed in 23. So
Thanks, Piyush. There was also a note added in relation to a much earlier question on surface area burn and satellite imagery. Just acknowledging that the total area burned by surface fires would not be particularly huge. If they're going to run and cover a large area, chances are they will be up and burning in the crowns. Surface fires are going to creep around and have relatively low rate of spread. Just reading here. So there was a note of thanks and that your May drought code maps were great. The fire progression maps you showed for BC, Alberta, and Northwest Territory Fire Complex made these wind events pretty clear. I would agree with that watching the animation. You guys are very chatty in the chat today. It's great. I love seeing people get involved with it. Great presentation. Okay, I'm just reading through. Evacuation question specific to Edson. This is specific to the town of Edson only. Does not include the rural municipality numbers. There were multiple evacuation orders captured where those additional numbers are captured in the database. So I think they're saying that the number you show would be town site only, whereas the other ones would be captured under a rural sum of numbers. And another person's noting for Edson, I lived it real time. Edson was roughly 8,500 residents, while Yellowhead County had roughly 11,000 residents, which was also evacuated. Most of the municipality on June 9th, only Edson was listed in the presentation. So I think you were only including municipal centers, not counties in your numbers at the beginning. Is that correct?
Well, the data is provisional as well. It's a lot of work to go through all the municipality evacuation orders and to verify them, and then sometimes they don't have numbers, so you have to, I think those numbers are inferred from census data, which is why they sometimes don't line up with, you know, what someone's personal experience might be. So if people have better data on evacuations and better numbers, I do encourage them to email. I guess they could email me and I can forward it on to the person who's putting together that data, because we're you know, more than happy to update the numbers with better data as it is available.
Thanks, Piyush. Did you want to drop your email in the chat, perhaps?
Sure.
I'm going to make you multitask. While you do that, I'm going to read you a question coming from Alaska. So one of the patterns we watch for in remote areas of Alaska that results in many remote lightning fires that are able to grow large is the breakdown of an upper ridge associated with lightning and then quick drying. Was this noted in any areas as a critical fire weather pattern to help fill in the gaps between indices and lightning counts?
Yeah, so some of that analysis has just started now as well. I think I noted that very large fire growth day, September 22nd, there wasn't actually a blocking ridge in place in that part of the country then, but there was a cold front moving through which had strong winds associated with it. And before that, it had been above average. I think Quebec might be those fires. Multiple fires started June 1st due to sort of lightning storms passing through. And before that, they did have a large ridge sitting there. And which has also corresponded to that rapid intensification of drought that I mentioned. So you had this very hot, dry period, and then I guess a cold front moved through with lightning or frontal passage of lightning and started a lot of those fires. And I think in BC, that's a very typical thing as well. When we were there, I mentioned we were on vacation in Penticton on that Wednesday when that McDougall run was starting to grow quite large. We went to the movies because it was 38 degrees Celsius and we could not bear to be outside for that day. And I think the weather did change. There was a change in winds at some point after that. I can't remember exactly. some of these case studies, this more, I sort of just showed big picture stuff, but some of this more like refined analysis looking at some of these individual events is still to happen, I think.
Thanks, Piyush. Kevin shared a report looking at the impacts of fire in 2021 and floods in BC. So thank you for sharing that. That link is in the chat box for anyone interested. One moment. Sorry about that. There was also a comment. In some areas with extreme drought codes, old burns of 5+ years were actively burning. Will this repetitive burning bring the boreal to more of an open primary succession forest, or will the soil damage lead to erosion in areas void of vegetation for a longer time? This is very much a fire ecology question. I'm not sure, Piyush, what your comfort level is in answering this, but I will use this time to plug that we do have Dr. Mark Parisian coming to talk on our webinar in April, and he'll be touching on more fire ecology. So Piyush, do you want to take a stab at this one?
Yeah, Mark can answer that in April.
What I can do is
I'm not a fire ecologist, so I don't want to misspeak. So I will leave that for other experts, and there's probably some people on this webinar who could probably put quite a good answer in the chat.
So if anyone wants to post a reply to that comment, please feel free to. Otherwise, Thomas, I will copy your question and I will forward it on to someone whose area of expertise that is and copy you in so you can get an answer to your question. Just making my way through here. Great presentation. People telling you to stay warm. I don't know about everyone else, but it was -46 ambient in Leduc, Alberta this morning. So it's very cold. Okay, there's a question about overnight recovery. Is overnight recovery, temp, RH, etc. on fires being impacted in the same way or to the same degree as daytime fire weather with respect to climate change and general drying?
That's a good question. So I'm aware of a couple of studies in this area. So one is that nights are warming generally faster than days. That's I'm sure that varies by region, but I remember there was a paper that came out with that. And then also that nighttime burning is becoming, I guess, a consequence of that is that nighttime burning is increasing basically in proportion to daytime burning. So there was a study from the US, I think, last year in Nature about Western US. They looked at nighttime versus daytime hotspots and looked at, they look at diurnal vapor pressure deficit or something. Anyway, to look at that question, try to address that question whether nighttime burning is increasing. So yeah, I think it's an active area of research. I believe Mike Flanagan and his student also have a paper coming out on nighttime burning soon. So maybe he can comment on that in the chat.
We'll see if you post anything. Mike, feel free to unmute if you want to as well. There was a request if you could give a similar talk to a different group. Piyush, I will forward you the contact information for that. I'm going to wait and see if Mike's going to chime in here for a moment. Okay, Mike, if you decide to chime in, just feel free to interrupt me. There's a question here about in some areas with a, oh, I just read that one. There was a reply about the drought with a link for a paper, which is great. Thank you. Talking about repetitive area burn, the fire ecology question. So thank you very much to Jessica for sharing a resource. To what extent can we expect future area burn to diminish based on the significant and increasing past area burned, i.e. new fires running into old fires? Is anyone at the Canadian Forest Service investigating or modeling these possibilities?
We are thinking about it, that's for sure. I know there's studies in the US where they have they incorporate fuel limitation terms into their models of area burned to try to get at that question. And I'm not aware that that's been attempted in Canada yet, but you know, years like last year do beg the question, when do we start to run out of fuels to burn, or to what degree is previous burns a barrier to burning? So Alan Whitman, who's one of my colleagues, does quite a lot of work in reburn, and also is interested in that question from a climate change perspective. So perhaps if she's online, she could put an answer in the chat, or if that we could refer to that person to Ellen, maybe.
Okay, perfect. I don't see Ellen on the call right now, but Kaiwei has chimed in. So Kaiwei is a Canada Wildfire graduate student, and his research work was done on drought triggers sustained overnight fires in North America. So he shared some resources with regards to that. Thank you, Kaiwei, and thank you, Lynn. Oh, it was also noted by Steve Cumming that the Spades team is working on reburn and fires running into old burns and decreases in area burn over time. So thank you for that, Steve. Okay, and he also shared a link as well in the chat. Thank you. So I don't see, oh, so there was a comment here with a question. The US media did not quite fully understand the realities of the Canadian fire regime, and when another smoke transport event happens in the Eastern and Midwestern US again, what would you say to the New York Times if you could?
What would I say? Well, I guess in terms of yeah, I guess provide some context about Canadian fire seasons, and the extent of the boreal forest, and in a bad year we can have a lot of area burned. I mean, this past year, it was because of those large fires burning in Quebec specifically that proximity is also a factor in smoke exposure, proximity to fires burning. So that was it got really bad there because of those very large fires, whereas the other region was Western Canada, and that smoke disperses somewhat before it gets to the other side of the country. So I'm not sure I answered that, but
No, I think that's perfect. Oh boy, everyone's posting it once again. Okay. I had a question, then I lost it here. When hectares burned or captured using mapping satellite data, is good fire or cultural burns and prescribed control burns included in the numbers? Are they lumped in with the bad fire years? Or lumped in with the bad fire each year? So I think they're trying to distinguish between intentional and I'm not sure what bad fire is really referring to here, because natural fire, even though not intentional, is not inherently bad. But I think the question is more about whether those intentional fires are being included in the numbers for area burn that you're sharing.
anything that's mapped regardless of ignition cause, I would say, is being mapped. I mean, a lot of experimental or prescribed burns can be quite small, so maybe they would not show up in the data that we've got. We tend to map the largest fires, which account for a very high percentage of the total area burned. So it's hard to say. When you get to the smaller fires, not everything is mapped, and certainly at this point, because we do not have the final MBAC product, there may be some fire events which are missing, but there's no, as far as I know, we do not map based on ignition cause.
Yeah, and it is interesting to note as well that jurisdiction varies greatly across the country and even within provinces or territories. So for example, in Alberta, we have a white zone and a green zone. So we have a forest protection area that's under the responsibility of the Forest Management Agency or Alberta Wildfire. And then we have this white zone, which is prairie rangeland. And so a lot of that fire you're talking about that's intentional or controlled or prescribed might be occurring in the white zone, but if it's not either supported or done in partnership with wildfire management agency, it might not actually be captured, especially if we're just talking about grass burns that wouldn't necessarily be caught by a satellite image unless it happened to fly over exactly in that moment. So there's a lot of nuances in there as well to take into account. Just looking. So it looks like some more papers are being shared, talking about reburn as well. So thank you, Denise, for sharing that paper. I'm not seeing any new questions. Every time I say that, one pops up, which is great. So we have one more. I'm going to take this as the last question, and then we're going to end at 11 o'clock and let Piyush get on with the rest of his work day. Piyush, do you have any data on fires burning in agricultural zones? Okay, so this is similar question. Do you know if there's a data source people can go to for agricultural zone fires?
Yeah, I mean, I don't know if those are consistently mapped. If you looked at I know they do show up in the CWFIS M3 polygon data, which is just based on essentially deriving polygons from satellite hotspots, because it just basically creates polygons from any fire event that's observed, whether it's in the agricultural zone or whether it's in different zones. So perhaps I can ask Peter Inglefield about that, to what extent those events are captured. I believe Dan Thompson at CFS has also done some work on grass fires. He might, I can reach out to him. So basically, I'm delegating that question to others, but I can find out.
I do see Peter on the call. I'm not sure if he wants to step in the last minute here or not, but feel free to if you'd like. Piyush, I'm resharing your email while we wait. Oh, Peter has noted that agricultural fires are excluded from M3 polygons. So thank you for that. There was some requests for me to share all of the resources that have been shared. So what I will do is I will go through the chat and gather together all of those resources and try to kind of put them under common themes. And I will email those out to everyone who attended today. It may take me a little bit of time to do that. This webinar, as you know, has also been recorded. So I will hopefully get this up early next week on our YouTube channel as well. Piyush, did you have any closing comments that you'd like to make?
No, just thank you for this opportunity to share some of this research, and it's a pretty wild season. So hopefully we will get a bit of a rest in 2024.
Thank you. I hope so as well. And I hope for those of you working in operations, you get a bit of recovery over this winter and aren't too bogged down in report and post-fire analysis and are able to actually get some time to recover before what is shaping up to be a potentially active fire season as well in 2024. I'd like to take this time to thank everyone who stuck with us for the extra half an hour. The conversation was great in the chat. It's always really nice to see people active and engaged. And Piyush, I would like to sincerely thank you for taking the time to put this presentation together and share with our audience today. For those of you still here, as I posted in the chat previously, in February, we have our February flare up, which is one webinar every Friday for 4 weeks straight, and we will be focusing on health. Head over to our website, canadawildfire.org/webinars and courses to learn more. And with that, I bid you all goodbye and have a great weekend. Thank you, Piyush.
Thanks.
Goodbye, everyone.